All right, so let's do the quick review. So the final exam, it's kind of divided into three different parts. That's what I noticed from when I was taking it. And the first section, so they're not separated explicitly, like you don't see them separate as section 1, section 2, section 3, but I noticed that they have like a common title in the top. And the first one, which I'm going to call section 1 for simplicity, the first section deals with things of interpolation, and least squares, deals with interpolation, least squares, and finite difference. Give me 1 second. Oigan, ¿se pueden callar? Dios mío. Okay, let's see. Sorry, I was reviewing what I was supposed to say. Interpolation, least squares, and finite difference. So for this type of problems, like for this three different type of problems in this section, what's going to happen is they will most likely give you something like this. And so you will be given an I. It's an I vector. You will be given an I vector, which is just gonna kind of like tell you your index. It doesn't really give you any important information or anything that you want to. You're not gonna do anything with it. But what is gonna be important is because it's gonna tell you your x. They're gonna give you an x vector, and your x vector is gonna have some information, like for example 0.1, 0.2, 0.3, 0.4, and they will also give you the evaluation of that xi. So the evaluation of your function at that xi, which could be something like 2, 3, 4, and 5. So they give you the index, which this you don't really need it. They give you the x value, which is the, again, if you're looking at a function and an x and y, they're pretty much telling you the value of that function at a particular x. So you can think of it that way. It's just a bunch of data that they're giving you information of. So with information like this, they can ask you the kind of questions that you can expect, and this will be the questions that you will see at the beginning. They can ask you for something like, hey, can you find the Lagrange multiplier, like for example the L11 of x. So what this means is that you have to come up with the polynomial equation. You have to come up with the polynomial equation, and then they can also ask you to evaluate it at a particular point. The trick here, or the thing to keep in mind, is that they will often say something like, hey, find the Lagrange interpolator of 1, and they will say use, or you will say something like using, like I want you to use x2 and x3. So these are the data points that they want you to use. And as you should remember from lecture, the number of data points that you need depends on the degree of your polynomial, what type of polynomial you're trying to fit. And after you come up with this Lagrange multiplier, which if you can recall correctly, the way that you find it, if I wanted to find for a particular I will call it degree, it will just be the big pi, the multiplier, and for j is not equal to 0, or I'm sorry, for j is equal to 0, and j is not equal to I, because otherwise it cancels, and is the degree of the polynomial. And I'm gonna have x minus xy. Let me see if I remember this correctly. Xi minus xj. If I remember correctly, I think the formula that you guys use in class is different. He has a k or something like that. But and I think Kasab uses both. He specifies both of the values here, like which is your which is going to be the degree of the polynomial, and the other one which is going to be the reference or something like that. So definitely keep this in mind. You will see questions with respect to this where the information will be given to you of those x values, the evaluation of the function of those x values. So you will be given the corresponding values for the function, and then they will ask you to come up with a particular order of the Lagrange polynomial interpolator, and they will specify you what points to use to accomplish that. And once you come up with the equation, so let me type here, you have to come up with a polynomial. You have to come up with a polynomial, and after you come up with a polynomial, then they will say something that and evaluate at x equals 3, for example. They can ask you something like that, which just means whatever polynomial you come up with. Like if you come up with a 2, 2, then you just have to evaluate it at 3, and this will give you whatever particular value they want you to plug into the as the answer. So you will use whatever. Again, just to a quick recap, they will give you the x values. They're gonna give you the evaluation and the function of those x values. They will ask you to find a particular Lagrange multiplier, or I'm sorry, a Lagrange. Yeah, I think it's called a Lagrange multiplier of a particular degree and everything, and they will ask you they will tell you specifically which points to use. And after you use the equation, this one is the equation that I remember off the top of my head. Your equation on your textbook or on your class notes may be different, may be simple or simpler, I should say. But you have to come up with a polynomial, and then after you have the polynomial, you have to evaluate it at a particular x value. That is what I remember with respect to that from when I was taking the exam. Another thing that they can ask you, so there might be like 3 different questions with respect to this, 3 or 4 questions of this, because they're gonna ask you for a linear Lagrange equation, and then they're gonna ask you, yeah, it's something like that. It's something what you're saying on the chat box. It's something like that, I remember, where it has like an xk, and that way you can specify like which one is it. It's something like I and k, and so then when you write it, you can write it with xk on the bottom and xi. It's something like that, because I think xi never changes. It remains the same throughout the whole multiplication, and I think they use k in your notes. But anyway, moving on, so I don't take all the time. So yeah, you're gonna have three equations or 3 questions that pertain to Lagrange interpolation. So definitely study that. We will also use finite difference. So if you recall correctly from the first exam, oh yeah, definitely look at the formula sheet. The formula sheet has all the correct equations, and if something is on the formula sheet, it will most likely be on the exam. I just noticed that they re-upload the formula sheet, so if you have an older version, definitely look at the new version. Maybe, I think it may include some of the stuff from least squares and things like that, which you're definitely going to need on the exam. So for finite difference, it's not going to be exactly let me just write it here. It's not gonna be exactly like in the first exam where it just said like, oh, evaluate the first derivative at this point or something like that. We're gonna use finite difference, but the context of the equation is gonna be different. If you guys remember from clamping, from the stuff that you cover in the class, when they say, oh, we have the point at the end that we have to clamp, and we have to evaluate the first derivative at those points. I've seen L1 or L1. What was the second number after the common mean? I think one of them, if I remember correctly, one of them has to do with the highest degree of the polynomial, like the degree of the polynomial, and I think the other one has to do with the x that you're using as a reference, but or the point that you're evaluating, and I really don't remember exactly. I just know that the formula might be different on the formula sheet. Definitely follow what's on the formula sheet. But For the finite difference, for the clamping conditions, and they will talk about the clamping conditions, and it might throw you off at first, but pretty much what they're saying is, hey, you have this data, you have the same thing as before. You have an x which has a bunch of values, you have an x vector which has a bunch of values, and you have a function that is evaluated on that x that also has a bunch of values. And let's say I'm going to type a bunch of 5s. And given something like this, you can apply finite difference. Why? Because you have data points. You have data points that you can use to do the forward finite difference, backward finite difference, and central finite difference. The difference with this type of questions is they will kind of like, it will have a lot of wording because they're talking about clamping conditions. They say, oh, if we want to find the clamping conditions, we need to evaluate the first derivative at those points, and then it just boils down to finite difference. That's what it is. You're just finding the first derivative or the second derivative of those clamping points by using the data, that they're giving you. They're giving you the x values, and they're giving you the evaluation of the function at those points. If you don't know the function for this, the function is on the formula sheet. The formula sheet has the correct equations because they're not the same as the ones for the first formula sheet, because there is a different order of accuracy. So they will say something like, oh, calculate the second order using the second accurate finite difference or something like that. Like they will specify at the beginning. So just make sure when you're looking at the formulas, you read exactly what they are and what they're meant for, and that you use the correct points, the correct data points for finding the value, because they will ask you like what values or what points specifically to use. Like they will say, oh, use x2 and x3. Like if I'm doing forward finite difference or something like that, and this is my guy of interest, and I'm gonna use this guy as a reference. So definitely keep that in mind when you're going through the formula sheet. Make sure you familiarize yourself with the formula sheet, and so that you know exactly where things are. But this is the questions that pertain to clamping. The questions that pertain to that set of questions will have to do with finite difference for the purpose of the exam. So it's just a matter of finding the finite difference. Did you do least squares or not yet? I have not done least squares, but least squares is on the exam. I'm about to get there. So for least squares, it has to do with noisy data. When they tell you something like, oh, you're given data that is noisy. So when they give you data that is noisy, you're definitely going to be using least squares. And what they can ask you for a question like this, for a question about noisy data, they can ask you like, oh, hey, what if we wanted to come up with a fit function? If we wanted to come up with a fit function that is in the form y of x is equal to ax plus a1x, if I wanted something like this, then I can ask you, okay, what are the values? So what are the values for a0 and a1? But most importantly, something that they're going to ask you is to come up with the equations, like with the set of equation. So come up. This will come first. So this guy comes first, and then from this you find the second one. So come up with, you have to come up with the system of equations. And if you recall correctly, the system of equations is something like this. So your system of equation is you have your matrix here, and you have the two coefficients, which those are what you're looking for, and then you have your right hand side vector. So this is one of the equations is coming up with this system of equations, and then the other one it's to actually solve for those values. So that's as far as you need to know for least squares. The other information that you need to know for least squares is they will provide you some information. They will provide you some data that you have to know how to use, and they will provide you two characteristic values. So you have to, as you're going through the exam, there is a lot of extra information that you may not particularly need at that stage, and you have to know how to go through it. So make sure you know how to calculate I'm gonna say know how to find Make sure you know how to find r square, which is the, I forgot what is it, the sum of the error square or something like that. I don't remember exactly, but you have to make sure you know how to find r square and how to find the standard error, which I think it's something like SXY. I think that's the notation that they use. So these two guys, you definitely need to know how to find them. You will be asked to find them on the exam. So this is everything sexy. This is this is all that has to do with the first section of the project, or I keep saying project, of the exam. So again, just a quick recap. The three main things, as I mentioned, you will be doing is interpolation, least square, and finite difference. Yeah, I think it's something like that. It's some equation. I'm sure it's on the formula sheet, so you just have to know how to use it. And the information that you have missing, I think is provided to you, so it's just a matter of plugging and doing. But yeah, so make sure you know how to do the Lagrange interpolation, how to come up with the Lagrange interpolator, like with the actual equation with a polynomial, and how to evaluate that polynomial. Make sure you know how to do finite difference of the second order accurate and first order accurate, the formulas on your formula sheet. And all the information you will be provided in this fashion. It will be provided in the, you have your x vector, and you're going to have the vector of the function, which is the evaluation of that x vector. And once you get to the noisy data, make sure you know how to find the fit function and how to solve for those coefficients, a sub 0 and a sub 1, and also how to come up with a system of equations. And then you have to find the r square and the standard error. That will be everything for section 1. So that moves us to section 2. So section 2, when I was working through it, what I noticed is section 2 has a lot to do with calculate. God, that's a horrible way of writing calculate. So we will be calculating integrals for the second section. So section 2 has to do with calculate integrals, and they will ask you to find the solution. So, or I can say solve integral. So they will ask you to solve integral using 1, 2, or more trapezoids. Yeah, it's gonna be 25 questions. I think it may be 26 unless they remove one of the questions. I think there is a question in there as a bonus or as a buffer, in case people miss any of the other questions. I'm not sure. I saw 26 questions. So, yeah, I think the time, I think it's 3 hours. I think the final is always longer than the rest, but don't quote me on that. But I think finals are always longer than the rest of the exams. Yeah, I think somebody was saying something like that during previous office hours or something like coño. Somebody was saying something like that during previous office hours. So definitely email your professor, and or you can email Kasap, or you can email the TAs, and we can always give you the exam earlier. Possible an ethics question or acknowledging that you will submit your strap paper. Yeah, there is a question about that. But anyway, we can talk about this after when I'm not recording, so we're not print. So yeah, you will solve an integral using a single trapezoid or multiple trapezoids. So you have to make sure you know how to do that, how to find the, using a one trapezoid, two trapezoids or more. Then you have to know how to find the error. So you have to know how to find the error between trapezoids. That's what I'm gonna call it. But what it means is, if you find the if you do your evaluation with two trapezoids and you do your evaluation of the integral with one trapezoid, you have to compare the error between those two, or you have to find the error between using two trapezoids and one trapezoid. So again, a formula that you can find on the formula sheets. And finally, you have to know how to do calculate. You have to know how to calculate using Romberg. So you have to know how to use Romberg integration. So you have to calculate using Romberg's integration. That will be these are the three, I will say, sections of calculating integrals without taking into account Gauss quadrature. So part of the same section, something that you're gonna see in this is definitely on the exam, as I told you before, is to find Gauss quadratures. And what part of Gauss quadrature can you expect? You can expect to be asked to find the linear mapping. So come up with the linear mapping. Which, if I remember correctly, is something like b minus a divided by 2 multiplied times the psi guy plus a plus b divided by 2. That will be the linear mapping, and a and b are your limits of integration, and psi it's the mapping. What's the word between trapezoid and the second point between? Yeah, between. It's a horrible way of writing between, but yeah. So find the linear mapping, and then you also have to know how to find the Jacobian. All these formulas are on the formula sheet. I believe the Jacobian is just the first part, so b minus a divided by 2. I think that's the Jacobian. This one is the linear mapping, if I remember correctly. And yeah, and then from there you just have to know how to solve using. So solve using Gauss quadrature, which, as you might expect, as you may expect, this means that we will give you, I think they will give you your weights, which will be like only 3 of them. I think you're using you're doing a 3-point Gauss quadrature. It's either a 2-point or a 3-point. If I remember correctly, I think it's a 3-point, and then they will give you your psi values, which of course are not gonna be these values, but I'm giving you. We're gonna 72 people. You should do a review. Yeah, no, not happening. But yeah, so those are your weights. Those are gonna be your psi values. That's what you're gonna be given at that section of the exam, and then that's what you're gonna be using to solve the whole Gauss quadrature problem. So again, this is the end of the second section. So the second section has to do with calculate integrals. You will have to solve integral using 1, 2, or more trapezoids. You will have to find the error between using a certain number of trapezoids and another number of trapezoids. So if they want the error between using 3 trapezoids and 2 trapezoids, then you have to be able to calculate that. You have to calculate integrals using Romberg integration. And then once you move into the Gauss quadrature section or part of section 2, then you will find the linear mapping, which is the function of x, or the function x as a function of the psi value, and you have to know how to find the Jacobian, and then you have to go ahead and solve the Gauss quadrature by hand. So that is with respect to that. Then I will talk about section 3, which this will be the last section. So the project, I keep saying the exam is divided into 3 main sections. Section 3 has to do with ODEs. With ODEs using, so ODE using Euler's method. Yeah, so the final was project 9 all along. Yeah, so you're gonna be doing ODE using Euler's method, and you're gonna be doing normal Euler's method. So Euler's It's so confusing whenever I'm writing Eulers, because I have the tendency, if I'm speaking in English, I have the tendency of call it EU, but because I took German, I took 4 years of German, then I know it's oi. You pronounce that as oi, EU. So yeah, you pronounce oi. That's why it's called, when you say Deutschland, even though it's written as this, you call it Deutschland. Okay, but anyway. Uh, Normal Eulers and modified. Normal Eulers and modified. Test review. Normal Eulers and modified. So make sure you definitely know how to do this. How to do normal Eulers and modified Eulers. Modify Euler's method. And the last question, the last question that I saw on the exam. So other than this, guys, other than solving using normals Eulers, modified Eulers, what's something of using the shooting method. For boundary value problems, for boundary. And this is somewhat of an advanced topic, I will say. So it's nothing extremely complicated. It's something like for example, if I gave you, and I'm just pulling this example out of my ass right now, but this is if I gave you something like the deflection of a beam, which it has this form. If you have something like this, and let's say I call that my function, and this function belongs to, so it's a finite beam. It goes from 0 to L, which is the length. And then if I gave you some initial conditions like, the displacement at 0 is 0, and then the force, and of course the area and the Young modulus changes because we're not in solid mechanics. And du dx evaluated where x is equal to the length. This will be an f naught, so that will be, that will be, there you go. So that this will be, this is the equation of the deflection of a beam from 0 to L, and then I have some initial conditions. What they're gonna ask you to do primarily is to come up with, you have to use finite difference and for the boundary value problems, and you have to come up with an equation, like with the actual equation. So the idea is that you use boundary value problems to solve differential equations. That's pretty much the case, and this is kind of like the beginning of something like finite element or those advanced classes, but you have to use boundary value problems to solve the ordinary differential equation, which means you're gonna move things around, you're gonna integrate, there are different ways of going about this. I don't know what method exactly they expect of you in this class, but this is one of the questions that is there, and they just want you to come up with the equation. So you have to come up with the equation. They're giving you differential equations. You have to come up with the equation. I'll just take the L for that one. Can you say how many questions per section? I think it varies. It varies. Some of there may be some conceptual questions in there which have to do. I think I saw like 1 or 2 conceptual questions that had. It has something to do with the like if you needed like local evaluation of the first derivative or something like that. I'm sure a question that you saw in class. Serious question. Why are we doing that advanced ODE stuff at a coding class? Because this is not a coding class, it is a math class. It just has coding in it, like everything else that comes after this. 1/3 will be fair to assume, I will say. They're divided into 3/3. So the first, that's why I divided into 3 sections. I will say each section has equally as many questions as the next one. So maybe if you're not good with the integral section, it's not like it's gonna be a bigger part than the interpolation and least squares. I've not learned any math in this math class till this last ODT. Yeah, that's what happens. You usually don't. I will say you don't learn anything with respect to this class until you're done with the class, and then you see it in a different class and you have to learn it. But yeah, that is everything with respect to this, with respect to the exam. So I'm just gonna scroll up and down real quick just to kind of like recap, and then after that I will stop the recording, and then we can answer some questions so this doesn't go on forever. But yeah, so the final exam review, again, interpolation, least squares, and finite difference will be section 1. They will give you your data points. You have to know how to find the Lagrange polynomial, how to evaluate the Lagrange polynomial. Then for the clamp conditions section, you have to find the you have to use finite difference to evaluate those first derivatives at those endpoints, at those clamp points. And for this, we're gonna use the finite difference method. You can find it on your formula sheet. Then once we get to the noisy data, you have to be able to come up with the fit function. For the fit function, you have to be able to create the system of equations that you will use to solve those coefficients, and then actually be able to solve those coefficients so you can report those as an answer. And you have to know how to find the R-square and the standard error. Those formulas, I believe they're on your formula sheet, and you will be provided all of the unknowns that you need to calculate the standard error and also to calculate R-square, if they're not obtained from the previous questions, which I don't think they are. So section 2 has to do with calculate the integrals. Make sure you know how to solve an integral using 1, 2, or many trapezoids, as many trapezoids as they want you to use. You have to make sure to find the error between those trapezoids. So find the error between using one method and the other method, and calculate those integrals using Romberg integration. And then the final part of the section 2 has to do with Gauss quadrature. Gauss quadrature, I've been telling you guys for a while that make sure you know how to do it by hand. And you have to know how to find the linear mapping, which I believe that is the equation. If not, the equation should be provided in the formula sheet. The Jacobian, you have to know how to find the Jacobian, and then you have to know how to actually go ahead and solve for the Gauss quadrature. So they will give you a set of weights and a set of psi values that you have to implement, and you have to carry on the process by hand. If all of this is new to you and you haven't seen it a single time, definitely check out Numerical Methods guy on YouTube. He has a bunch of videos of these different methods with examples. So make sure you go and look at that. But section 3, which is the last section, ODE using Euler's method. So normal Euler's method and modified Euler's method. Those are the two big guys in this section. And then there's one question. So the normal Eulers and modified Eulers, that will be the big chunk of this section. The shooting method for boundary value problems, it's only one question if I remember correctly. And it's a question similar to this. It's not necessarily this, but it could be any type of second order problem. It could be a vibration problem. I think this one is the deformation of a beam, and they will give you the differential equation with some boundary conditions, and they just ask you to come up with the equation that represents this system. And that's it. That will be everything for the final exam. So I'm gonna stop the recording now, and I'm gonna answer some questions.